Hi everyone. Okay, so basically how the screencast is going to work is I'm going to go over the lesson the same way I would at the front of the class. And so you're going to fill in your note sheet as you go along. You can pause whenever you want or rewind to listen to an explanation again. And then tomorrow we're going to work on the homework in class. Okay, so in this screencast we're going to go over the rules of how to solve equations. We're going to talk about what that means and we're going to practice, of course. So the learning goal is to be able to isolate and solve for a variable, which will make a lot more sense when we go over some definitions in a second. Okay, so an equation is an algebraic expression with an equal sign. For example, if we have something like 3x is equal to 6. So if we have that, we now we have an algebraic expression. Remember, algebraic expressions have numbers and variables, but now we've added that equal sign in the middle, which we never really had before. We also have, we can solve an equation. So what that means is we would be finding the value of the unknown variable. So remember, variables are just placeholders, and they can be letters like x, y, m, or n. So they're just holding a spot for a number. So if we wanted to solve an actual equation, if we had something, for example, like 3x is equal to 6, okay? So if we had something like that, we want to find out what x is. So what we would do, and we'll talk about y after, is we would divide both sides by 3, and we end up seeing that x is equal to 2, okay? So the reason for this is because 3 times some number that we don't know is equal to 6. And so we're working out in our head, or in this case with our algebra, that x is equal to 2. So at the end of it all, instead of having some polynomial expression that has x's in it, we're going to have the x actually equal to a number. The last definition we're going to talk about is isolating a variable. So this is when we rearrange the variable on one side of the equation by itself. So essentially what we're trying to do is we want to be able to get the variable alone. See how that x equals to 2 here is just a variable equals a number. That's our goal. We just want to have it equal to something plain and simple. Okay. So when we're isolating, pretty much what that means and what that's telling you in a question is you're getting the variable by itself. You want nothing else beside it, in the same way that this x is by itself. It doesn't have the 3 beside it anymore. We got rid of it and we have the variable alone. So there's not really a difference between what we've done with the second and third definition. Solving just means you're finding what the variable is equal to. Isolating is like the process we're using to get there. So the process to solve is to get x by itself in order to have it, to figure out what it's equal to. Okay. All right, so our general rule is that the equation has to be kept balanced at all times. And we use opposite operations to isolate the variable. Okay, so what does that mean? So let's say we have something like x plus 1 is equal to 6. Okay, if I actually draw a little balance here, so I'll get this balance beam, and I'm going to put the equal sign in the middle. Okay, and then I'm going to write each side of the equation on each part of the equation on either side. So we have this x plus 1 and we got equal to 6. Okay, so then we stop and we say, okay, what do we have to do to get x by itself? Because we want to get x by itself in order to solve. We want to isolate the variable in order to solve for x. So we're going to use the opposite operation. That's what this means. So in order to use the opposite operation, if right now there's a plus 1, it's x plus 1, we're going to do the opposite. Okay, so because there's a plus 1, we're going to subtract 1. We want to get rid of that 1. It's kind of like you're saying if you subtract 1, you get a 0 on that side, plus the x. Okay, so if we put a minus 1 on that side, we also have to put it on the other side, because that's what the balance means. It means whatever we do to one side, we have to do to the other side. And then what you're going to get is x is equal to 5, because you've created this situation where you have a plus 1 and a negative 1 here, which is going to be 0, and then a 6 minus 1, which is equal to 5. Okay? All right, so let's look at our first example. We have x plus 4 is equal to negative 10. Okay, so our goal is to get x by itself. Okay, so I'm going to write down an x because we want to get that by ourselves. That's our goal. Okay. In order to do that, we need to use an opposite operation. So right now, that 4 here is being added to the x. So what we're going to do is the opposite. We're going to say, okay, we have a 4 added, and now we're going to subtract it to get rid of it. Okay, the whole point is to get x by itself, so we need to get rid of it there. So to do that, we add the 4, that's the equation, and we subtract 4. So we're going to do minus 4, but if we do that on one side, okay, so that's going to give us a 0. That's going to get rid of it on one side. But the problem is we need to keep it balanced. So if we did it on one side, we have to do it on the other side, that negative 10 that's on your sheet there. Okay, so negative 10 minus 4 on the other side, that keeps it balanced. And so do you see how both the negative 4s, that's the thing we've changed, but because we've done the same thing to both sides, it hasn't actually changed the question. It's just rearranged the numbers a little bit. And that makes it easier for us to solve for x, okay? Because those two numbers are going to cancel out to be 0, and then we're going to have x is equal to negative 14. Because remember, when we add negative numbers, if the sign is the same, you keep that sign, which is the negative, and you add the number, so 14. So we've now solved for x, and we've got negative 14. All right, let's try another one. So we have 5n is equal to 35. All right, so 5 times some number is 35. Now, we want to get n by itself. And in order to do that, we do opposite operations. So whereas up here, if 4 was being added, we needed to subtract it. That's the opposite operation. So adding and subtracting are opposite. Similarly, multiplication and division are opposite. So this 5 is being multiplied by the n. So we're going to do the reverse. We're going to divide it by 5. Okay, and what that does is it gets rid of this section, because 5 divided by 5 is just 1. So if we have 1n, that's fine. That's just the same thing as n, and we've now isolated the n. Okay, but if we do that on one side, you just saw we have to divide the other side by 5 as well, because we want to keep it balanced. Okay, so we've now done the same thing to both sides. We've gotten rid of the 5s, so now we just have n by itself. And then we have n is equal to the 35 over 5. And then you can say, okay, well, 35 divided by 5 is just 7. So n is equal to 7. And so what you've done is you've said 5 times some number is 35, and the answer is 5 times 7 is 35. A lot of the times, and this is going to be done in your homework tomorrow, sometimes they ask you to solve it by inspection. So that means just looking at it and thinking about it. Some of these are really easy because you can say, well, what number times 5 would give me 35? And it's 7. But this is the actual algebraic way to solve it. Okay, so now we're going to move on to the last example here. So m minus 9 is equal to negative 1. And we're going to do the same thing, opposite operations. So if I'm subtracting 9 there, it's almost like I'm moving it over. So what I mean by that is you don't always have to write out that you're doing the opposite operation, but it's almost like you're taking that negative 9 and bringing it over to the other side, and it's becoming positive. It's switching signs. It's the same effect, okay? So that's another way to think about it. So if we do m minus 9, we're going to add 9 to get rid of that 9, okay? Same thing we've been doing, and so we have to add it on the other side as well. But see how what we did is we actually all we actually did on the other side is we added 9. So we could have not written that first part at all. I'll show you what I mean in a second. So if we have this, we haven't changed the equation, right? We've done the same thing on both sides, same as those negative 4s, same as the 5s and b. And now we've gotten the 0 here, which is what we want because that leaves m by itself. Okay, and that's equal to 8. So m is equal to 8. The other way to do it is to just write m is equal to negative 1 plus 9. So what that means is it's almost like we've just taken this negative 9 and moved it over to the other side, but it changes sign. Okay, so we're just not writing the minus 9 plus 9 part. But it's doing the exact same thing, and that's what we're going to work towards, is just writing m is equal to 8 like that. Okay. All right, so our next example, we want to get x by itself again. So what we're going to do is we are going to write x by itself, and we are going to multiply both sides by -3 because we're doing the opposite operation. So if I multiply this side by -3, we have that one situation happening. But if I do it on both sides, that's what keeps the equation balanced. Okay, so I'm going to end up with 12 times -3, which is just x is equal to -36. In the next example, we're going to move that 8 over, so same thing, we're using opposite operations, but what that's doing is subtracting the 8 on both sides. And so we can just write it like this, 2 minus 8, and we get 6. Okay, so it's the same thing as saying plus 8 minus 8 over here, we're just not writing it. We would be subtracting the 8 here to get 0, but we're also doing it to this side. So I've skipped the step where you have to write it in between, and that's okay. So the other way that I said we can think about it is that we're just moving this 8 over to the other side, and when we move it over the equal sign, the sign changes. Okay, and you get x is equal, w is equal to -6. In this last example here, we're going to divide both sides by -6. Okay, opposite operation, we're going to get rid of it on one side, and -18 divided by -6 is going to give us +3. Because negative divided by negative, remember, is equal to positive. In our next examples, it's important to remember our goal. We want to get the variable by itself, okay? But there's two steps involved in this because it's not just a number added or multiplied to the x anymore. Now we have a situation where we've got a number multiplied and added. And so when we're doing something like that, the way I think about it is if we can't get the x by itself just yet, what's the next closest thing? And that's to get the 5x by itself. That's the closest thing to the x, so we're going to work towards getting the x by itself, but first we're going to get rid of this 7 here. Okay, so we're going to do the same thing we've been doing. We're going to move it over to the other side, so that's going to be a -7 on the other side. So we can simplify that now, because 2 minus 7 is just -5. And then now we can divide this x by 5 on both sides. Okay, so when we divide it, you get that 1 on the other side, so it's just x by itself, and we find that x is equal to -1. You'll notice I've added this part in here, so you can pause the video and take a look at that. It's just making note that that's if you were to have divided by 5 first, which you would have still gotten to the right answer, but it's way too complicated because essentially you have to divide everything by 5 if you do that. We'll go over something like that in class tomorrow, so don't worry too much about it, but you always want to do that addition and subtraction before you worry about the multiplying by x, okay? So in this example, we want to get n by itself. We can't right away, so we're going to get 7n by itself first, and we're going to do that by moving the -11 over to the other side. It's going to become positive. We're going to simplify, so we're going to get 7n is equal to 7. So here I'm just showing you that the sign has changed and the 11 has moved over. So we're going to simplify to be 7, and then we have just left n is equal to 1. In the next example, we want to get w by itself. So in order to do that, we're going to move the 8 over first, get that out of the way, because we can't get the w yet by itself, so we're going to get w over 2 by itself. So that +8 becomes negative, which simplifies to -12. And then now to get the w by itself, we're going to do the opposite. So because the 2 is being divided right now, we're going to multiply by 2. And so by doing that, we get a situation where we have w by itself, and then you're just left with w is equal to -12 times 2, which is equal to -24. Okay, pause the video and try D, and then I will post what D looks like. So pause now. Okay, and there's your answer for D. So copy that out and make sure you got the same thing. You're going to do the same thing for E, so pause the video and give it a try, and I will post it. So pause now. Alright, and you can check your answer for this one. For the sake of time, I'm showing you what F looks like. So that's the first part of it, so you can pause to see that, and then the other part is, that's your final answer, should be 5/12, just because there's not a lot of time left, so I'll work on that for tomorrow, but we can go over this example tomorrow. So this is what you need to do for tomorrow. Bring your note sheet in, I'm going to check that it's done, and come with questions, and we'll work on homework in class. I'll see you guys tomorrow.